If your diaphragm pump is not pumping water, the first thing to do is understand what kind of failure you have. There are two different situations. In the first one, the pump is completely silent, you turn it on and nothing happens. No motor sound, no vibration, no click, no attempt to run. In the second one, the motor runs but no water comes out, or the water only sputters. Those two problems have different causes, so do not start by taking the whole pump apart. Start with the symptom. Let's begin with a 12-volt diaphragm pump, like the kind often used in campervans, RVs, boats, and small water systems. Before checking anything, turn the pump off and disconnect power. If the pump is connected to a battery, disconnect the supply or remove the fuse. Also open a tap to release pressure from the system. If the pump is completely dead, start with the simple electrical checks. Check the fuse first. A blown fuse is one of the easiest causes to miss. Also check the main pump switch, the ground connection, and any loose or corroded terminals. A pump can look faulty when the real problem is only a bad connection. Next, use a multimeter set to DC voltage and check whether the pump is actually receiving power. On a 12-volt system, you should normally see close to battery voltage across the positive and negative supply terminals. If you do not have voltage at the pump, the problem is upstream, fuse, switch, wiring, ground, or battery supply. If you do have voltage at the pump, but the motor does not run, then the next part to check is the pressure switch. Many diaphragm pumps are demand pumps. That means they turn on when pressure drops and turn off when pressure reaches the shutoff point. Inside the pump head, a small diaphragm reacts to pressure and operates a micro switch. When the system is pressurized, the switch opens and stops the motor. When you open a faucet and pressure drops, the switch closes and the motor runs again. If the pressure switch is stuck open, misaligned, damaged, or not passing current, the motor may never receive power even though voltage is reaching the pump. With the pump safely isolated, you can inspect the switch area for loose wires, corrosion, water damage, or a damaged switch diaphragm. If you are comfortable using a multimeter, you can check whether voltage reaches the motor side of the switch when the pump should be running. Do not bypass the pressure switch as a permanent fix. It is there to stop the pump when pressure is high. Bypassing it can cause overpressure, leaks, overheating, or damage. Another possible cause is the thermal cutout. Some pump motors include a thermal protector. If the motor gets too hot, the thermal cutout opens the circuit and stops the motor. After the motor cools and power is removed, it may reset. So if the pump stopped after running for a long time, cycling rapidly, or struggling against a blockage, let it cool. Then check why it overheated. Low voltage, a jammed pump head, a blocked line, rapid cycling, or a stiff motor can all make the pump run hot. Now, if power is present, the pressure switch is working, and the motor still does not run, the drive assembly may be locked. Inside a diaphragm pump, the motor turns a small drive mechanism. That movement flexes the diaphragms and creates suction and pressure. If the shaft, bearings, or drive mechanism is seized, the motor may not start. With the pump disconnected from power, you may be able to remove the pump head and gently check whether the drive mechanism moves. If it feels stuck, gritty, rusty, or crunchy, that can explain why the pump will not run. Sometimes the problem is corrosion, old water residue, frozen damage, worn bearings, or a stiff crank assembly. A very small amount of suitable grease may help if the problem is dry or stiff movement, but do not pack grease into water chambers, valves, or diaphragms unless the manufacturer allows it. If the motor itself has failed, or if the pump has been overheated, or water has entered the motor, replacement may be more practical than repair. Now let's look at the other common situation. The motor runs, but the pump does not pump water. In that case, the electrical side is probably working. Now you are looking for a water flow problem. First, check the water tank. It sounds obvious, but if the tank is empty, the pump will only pull air. Next, check the inlet strainer. Many diaphragm pumps have a small strainer before the pump inlet. If it is full of debris, plastic shavings, algae, limescale, or sediment, the pump cannot draw water properly. Remove and clean it. Then check the suction line. The inlet side of a diaphragm pump must be airtight. A tiny air leak can stop the pump from priming. The pump may run, but instead of pulling water, it pulls air through a loose fitting, cracked strainer bowl, split hose, or bad connection. Look closely at every fitting between the tank and the pump. Tighten loose connections, check for cracks, and make sure the hose is not collapsed. Also check for kinked hoses or closed valves. A winterizing valve, shut-off valve, or tank selector valve in the wrong position can completely stop the pump from getting water. If the pump still runs but does not build pressure, the problem may be inside the pump head. Diaphragm pumps use small inlet and outlet valves. If debris holds those valves open, water can move back and forth inside the pump instead of being pushed forward. The result is low flow, no flow, or a pump that will not prime. Open the pump head only after disconnecting power and relieving pressure. Keep track of screws, seals, valves, and diaphragms. Take photos before removing parts. Look for dirt, swollen rubber valves, a damaged diaphragm, a cracked housing, loose screws, or water in the drive area. If water has passed into the drive assembly, the diaphragm may be punctured. Service kits are available for many diaphragm pumps, but you need the exact model number. Do not assume every pump head, valve kit, or diaphragm kit is the same. When reassembling the pump, tighten screws evenly. Do not over-tighten plastic parts. Reconnect the hoses correctly. Restore power. Open a tap and test the pump. If the pump starts, pulls water, builds pressure, and shuts off normally when the tap is closed, the repair has worked. If it runs continuously and never shuts off, check for leaks, trapped air, bad valves, a faulty pressure switch, or a pressure setting problem. If it pulses on and off rapidly, check for restricted plumbing, clogged faucet aerators, low flow fixtures, or an accumulator issue. So the safe troubleshooting order is this. If the pump is silent, check the fuse, switch, wiring, ground, voltage, pressure switch, thermal cutout, and locked drive assembly. If the pump runs but does not pump water, check the tank, inlet strainer, air leaks, suction hose, valves, kinks, check valve, pump head, diaphragms, and internal valves. A diaphragm pump is simple in principle, but it depends on three things: power, movement, and a sealed water path. If one of those three is missing, the pump will not move water. And if you are not confident working with electrical connections, batteries, pressurized water, or pump internals, stop and get help from a qualified technician.